This is question number 17, part A, and we are told figure 12 shows a simple machine. So we have this is a lever machine, we have the rod, we have the effort there. On the same figure, mark and label the following parts: effort arm and rod arm. So from here to here, this is where we have the effort. So this is effort arm. From there to here, that is rod arm. So you get one mark there, you get another mark there, and that is marks for part A. Let's go to the next part. Part B of the question number 17, we are told figure 13 shows a pulley system used to raise a mass of 5 kilograms through a height of 2 meters when a force of 60 Newton is applied. Acceleration due to gravity is 10 meters per second squared. That is the acceleration. So we have the pulley system here. We have the effort, 60 newtons. We have the rod. Here we have the rod. So the question is, determine the distance moved by the effort. So we can say effort distance is equals to 2 multiplied by rod distance, which is equals to 2 multiplied by the road moved 2 meters, so it is 2, so it is equals to we can say here it is 4 meters. So that is the distance moved by the effort. Roman number 2, we can say work done is equals to force multiplied by distance. So this is equals to the force is equals to 5 kilograms multiplied by, that is 5 kilograms moved by up by, that is the road. We convert to newtons, that is 5 times 10, and we multiply by 2, and that should give us this is 50 times 2, that is 100 joules. Roman number 3, potential energy gained by the road. We normally say potential energy is equals to work done, which is equals to m, the mass, multiplied by gravity multiplied by height, which is equals to the same as work done, which is 5 multiplied by 10 multiplied by 2, and that should give you 100 joules. So potential energy and work done are the same. So that's how you answer part B of this question. Let's move to the next part of the question. This is part C of the question number 17, and we are told figure 14 shows a setup that can be used to determine the specific latent heat of vaporization of water. A beaker containing some water was placed on a weighing balance and an immersion heater rated 500 immersed in the water. So we have, this is the immersion heater, we have water, this is a beaker placed on the balance like that. So the question is, state how the mass of the steam can be measured using this setup. So we can get, after heating, there will be some loss of water through evaporation. So we can say we can be able to measure the mass of steam by getting difference in initial and final reading of the beam balance. of the beam balance. So that is how we get the mass of steam that can be measured using this setup. Let's go to the next part of this question. The next part of this question, we are told, write down an expression for the heat supplied by the heater. So we are told that the rate of heater is 500 watts. So energy supplied is equals to 500 multiplied by time taken. So that is the expression. Roman number 3, determine the specific latent heat of vaporization. So we can say heat supplied is equals to heat gained by the system. Which means that 500 is the heat supplied. 500 multiplied by time taken is equal to mass multiplied by the latent heat of vaporization. So we can say latent heat of vaporization is 500. We make RV as a subject, and 500 T multiplied by the mass. So that is the expression that can give you the latent heat of vaporization. And that is how you answer that question. Here you get 4 marks.